Yeah, there you go.
Power on. Bluetooth already opened. Power off. Power on. Bluetooth already opened. Power on. Bluetooth already opened.
Where you got all the speakers at?
Nothing successfully.
Oh, I see where they're at.
Yeah, hopefully.
And there's speakers and mics or no?
Mic's up here.
Okay.
So these are just for the people to hear, because last
Yeah,
time.
and the mic, if they want to get up and talk, they should get up and talk.
I think it'll hear it, but this time I'm just gonna mute it during when he's talking, and if they have questions, I'm gonna let them know. Yes.
Yep.
That was the big echo last time I heard, when I watched the video.
Already opened.
I don't even wanna put it on the.
Interesting.
Hey, you ready to go out?
Huh?
University.
Oh, okay.
Power on. Bluetooth already opened.
So. I'm really going down the first.
No. That's funny.
Power off.
Well, they do.
Just. Yeah, I'm just looking. You go. Okay. Keep checking.
Power on. Bluetooth already opened.
But him and
Power off.
And you don't give. There. It's part. Spend it. Walk on.
oh, here.
Here. What's talking about? I'm not sure who's doing.
I heard it.
10 of them. Yeah, we're doing. But I'm in for the, Wander down and we saw that I'm stuff like that. No, people are. Yeah. Yeah.
Your pen runner for a second.
Yeah, I'm sorry.
Nor.
What's up?
No, just put your name. Ready? Send you a message.
Hey, exchange 3 of them, I see. When you got the Zoom, they're waiting for that meeting. No. Okay, yeah, we're waiting. If you want 10 minutes, man, just let me know. Okay, yeah, we're ready for you to join in, and then you should just be able to request share screen, and I'll let you go at it.
Yeah, all right, yeah, there, it's pretty.
You gotta match it with
Yeah.
the high school I see those.
You don't want the screen?
No, not Vernon.
You're not gonna have it.
I'll Vernon next door. Vernon?
Say
That's right. I'm Vernon. Right, next to Vernon.
That's you? Don't worry. That's not a shame, man.
So, I think I did last time, you're still in,
Sir,
no,
Yeah.
sometimes. What was his the last?
What was your name again? Your other homie trying to go to Cincinnati? Oh, yeah, his name.
Like I don't
What was his name? Yeah, Joseph. He applied it now. It's like him. Yeah, that's what I heard.
Not quite yet.
Yeah, later like that. That's what.
How about now?
Yep, can you hear me now?
Yeah, I think I just gotta switch the volume again on this. So we got speakers.
Okay.
Not enough work, so we don't warm them up. I knew you were gonna do that.
There we go.
Again.
Can you guys hear me okay?
Well, I got you on the computer. I'm trying to get you over to our sound system.
Oh, okay.
Hours. What I figured out.
Let's do this again.
Never happened. Which is it?
Hey, can you speak again?
Yeah, checking mic check.
No. Oh,
These were the only they visit us. People, yeah, this is gonna go set up like 6 panels.
okay, can you try one more time?
I don't last time. Jackson. I already fixed one. And then my.
Sorry about that. How about now? I switched I accidentally closed out that other window.
Got out of the when we closed the door. It's tight. And we kept pulling on the wire and pulling this other.
Hello, Andy, are you there?
Yeah, can you hear me? Can you hear? Can you hear
Hello?
me now?
Thumb's working right now. Yeah.
Okay, good deal.
Right. Well, it's not speaker. It's going. All right, we got Andy with Neptune here for gas detection and gas detectors. And if you just share your screen, Andy, we should be able to go.
Okay, great. Did we get a good crowd tonight?
About 20 people total via Zoom.
Oh,
And
wow. Nice. You guys got a nice size chapter then. I appreciate it. Thanks for having me here. I'll start sharing. Let's see. This host disabled attendee sharing screen sharing. Let's see. Okay. I think I've got this right. You guys let me know if you guys can see the screen sharing here going on. Can you still hear me?
yeah, can you try sharing one more time?
Yeah, here we go. Entire screen. There we go. I'm screen sharing now. So this is me previewing it, I guess. Maybe I need to double click this. I'm not necessarily used to this one.
Yeah, we're learning too.
Yeah, let's see here. I'm trying to get it to go full size. Pop out, minimize. Let's see here. Can you guys, you probably can't see this very good if you're seeing what I'm seeing. Let me double click
Yeah.
this. See if this will go up, go down. Can I second mouse click it and go full screen? Let's see what this does. Optimize for video clip. Huh. Let me see here. I was thinking I could go full screen, but this doesn't look like it's going full screen very well for me. So let me see here. Let's see what the view looks like.
At the bottom, it says full screen.
Let's try this. Yeah, that's not really. This little thumbnail, is this all you guys are seeing? Is that size right there?
Yeah.
Okay. So I'm not for sure on the view here what's going on. Here's speaker view. Here's gallery view.
Try gallery.
Try gallery view.
Yeah, we could try them all over the screen.
Optimize for video clip. Let's see what that does. Nah, we don't want to optimize for video clip. Let's take that off actually. There. Well, what else we got here? Yeah, as far as blowing this up full screen, I'm having trouble, guys. So what we might do is, I would think that I could figure this out, why it's doing that. It might have to do with the recording part of it. I wouldn't think so.
Do you have a camera on right now?
Yeah, my camera's on, or I've got it covered, but my camera is available.
Can you disable that? Maybe I can just see your screen that you're sharing.
Let me see. Well, I've got this. I'm working off the porch today, guys, so that's why I've got this on here. But you're saying disable this one. Let's see here.
Yeah, I think maybe we can just see your screen from there.
If I stop sharing, stop video.
Yeah, just your video because you'll be sharing your screen.
Okay. So let me see. Yeah, I wish I would have had a little more video settings. Yeah, for some reason, I'm not sure why the screen icon is so small. I'm not used to seeing it this small. But what we can do is, I figured if I double click it, preview. Let me try to exit out over here on this chat side. See if it gets any bigger. And let's go to speaker view and see if we can get this any bigger. That's so weird. What's this? Resume share. Oh, you're sharing the screen. Well, let's see here. Maybe I'm missing something. Let's go escape. You guys don't see that.
Yeah, I see your screen.
You can see the screen now.
Yeah.
Can you see the?
Yeah, we just need to be off Zoom, actually. I think that try to go online and see if we can see what you're trying to share. You guys
Can
see
you
that?
see? You can actually see my screen now.
Yeah, we were just staring at the Zoom meeting. I didn't realize what was going on.
Oh, okay. Shoot. Sorry about that, guys. That was my. I've done Zoom, but it's been a minute, so I apologize. One of the things I want to go over is I'll go ahead and get started real quick. I was going to go over, and you guys want to go for about half an hour or 40 minutes? Does that work for you guys?
Yeah, 40 minutes, good.
40 minutes, okay. So I was going to go over the gas detection systems, ammonia systems, and a couple examples that CTI has done over the years, and some helpful documents online that will help with the codes and following the output functions that we should be doing with these gas detection systems. And so I'm sure you guys have maybe seen this before, but I was going to show you a couple helpful resources here. And one of the resources was from the CTI Gas website here at www.ctigas.com. We have a resources tab up here, and we have a codes and design location. So every gas detection company will have should have some documentation on really kind of what OSHA says, design your systems according to the manufacturer's recommendations, right? And so a lot of people miss that part of it. CTI is not trying to twist any arms in this venture, but we're supposed to be able to try to put together a document that helps people design their systems in a way that the system's supposed to be functioning in order to capture leaks. And so CTI put together this document which covers all the code related things that we're supposed to be doing with gas detection. We go over a lot of the locations of the sensors in here and what sensors should be kind of found, what order numbers should be found in those locations, and what you'd normally see those alarm set points being in those locations throughout your facility, right? And so we cover that part of it, and then we go down and we cover the IAR standards where they're telling us, well, what should we be doing with these systems? And so CTI tried to make it a little helpful, because this is only a 15-page document, as you can see here. And we went in and said, let's just grab up everything that we were doing before. And now that they're all referencing this IAR2 standards, right, to comply with the IAR2 standards, let's go in here and make it easy for everybody to see what we're supposed to be doing. And so, as you can see, we've come in here and we've searched by location of all these different sensors throughout the refrigerated spaces and package systems and machinery rooms and equipment pits and what they call out for level 1 and level 3 detection. And so we went in and defined, well, what are we supposed to be doing, right? And so we broke it out again. What is level 1? What is level 3 doing? And what is the machinery rooms doing? And this is the output functions that you would be seeing from the standard. And then you would be seeing this from what CTI recommends. So this is kind of what the manufacturer's recommending, right? And as you well know, these are pretty straightforward, but one of the things to be aware of on that last October 2021, right, is that 2 detectors of identical ranges showed up in the codes. And so a lot of folks in their compressor rooms will only have, if I go down this last page here, we got a couple examples of our systems. One example is of the original GG6 standalone system that gets a home run from each sensor back to the controllers. And then if you have to expand them, you can add 8 more and more relay outputs. And here's all of our outputs. And so one of the things that we wanted to show on these drawings is the part numbers and the ranges of the sensors. You can see that this document's real helpful in seeing, okay, well, in the compressor room, we got 2 low-level 0 to 250 range sensors, right? That's going to trip at 25 parts per million. Either one of these sees 25 parts per million, you're going to get your audio visual. And then at 150 parts per million, we're going to do what? We're going to latch on our ventilation output here. So this is some of the output functions that you would expect off the system, along with the e-stop. And so when you're designing your systems, one of the things to always be aware of is hey, it's one thing, let's get all of our sensor points figured out. And as I showed before, CTI does recommend this high-level sensor in their design, because once you go to 250, and then somebody's responding to a leak, the fire department is usually going to ask, have you made it over 10,000 parts per million yet? If the fire department is supposed to be responding for your to help you out on that release, right? And so they like to kind of know if all the more you can read off your controller is 250, then you really don't know if you've reached 10,000. So that's one of the questions they like to ask, is my understanding is when the fire chiefs show up and the authority having jurisdiction and they have to do a life-saving event, a lot of times they're going to ask, you know, are you over 10,000 or not? So when you're monitoring these systems, you know, by for code, that monitoring can be, you know, it could be to the fire department. They could be saying, hey, we want to call at 25 ppm. Or they could say, well, we don't want you to be bothered at 25 ppm. Start calling us at 150 because we don't want to send the fire department down there 4 times a year just because you're changing oil and you accidentally didn't get the fans turned on some of these sensors, right? And so that's kind of what we're used to seeing for some of these output functions. And of course, having the reset button inside the compressor room, you know, that is code. You're supposed to reset this system from inside the compressor room after a leak is mitigated. And so you'll see a lot of the reset switches being inside the compressor room. Sometimes if the controller is in the compressor room, then they're covered. But a lot of folks have been moving that controller back outside the compressor room because it makes sense to see what these values are outside instead of trying to read them in here, unless you're remoted in and have the ability to, you know, remotely log in to another system. Like I'm up here in Chillicothe, Missouri, about 2 hours north of Columbia, and I'm just going to log into that new M255 system over there in Columbia. So right now, this system's sitting in Columbia, Missouri, and I'm about 2 hours north because I got a little VPN connection here that I'm using to connect to their network, and so I can see all these sensors, you know, from this system. And you guys are probably used to seeing that screen look something more like this when it comes to, you know, looking at this color touchscreen controller. But so that's pretty convenient, really, to be able to take care of that monitoring, you know, on a web-based system. The next convenient thing between systems that I'd like to talk about would be, well, first of all, I should ask if there's any questions so far on output functions and on sensor coverages and sensor locations. If you guys have any questions on that at all, about where these sensors need to be located and what ranges, if you have any questions on the ranges, if you have any questions on vent relief sensors. You know, vent relief sensors are not code. I got a feeling they're going to be code someday because the reality of it is you know, some vent reliefs can actually be pretty catastrophic. I mean, those vent relief sensors are 0 to 10,000. As you can see, they can have a lot of ammonia come out of them. And usually that's, you know, they'll be turned up in the air. You shouldn't see that happening that way because, you know, most of the time we're bullhorning them upwards at a 45 degree, right? But vent reliefs can throw quite a bit of ammonia out there in the parking lot. And so, you know, if you have the daycare over there next to you, or if you have the school over there nearby, or your folks coming out, you know, and parking out around the compressor room, and you got some vent relief sensors out there that could drop a cloud like that down onto them, then a lot of times you might see that being used, and you could call that good engineering practices, just for the simple fact is you know when it happens. You know, you're going to know when that release happens, and whether or not, if the weather's right, if that cloud is dropping down on a parking lot or not. So I wanted to bring that up as well too, because I know a lot of people go ahead and install these, and it's pretty common in our industry to put a vent relief sensor. This is 0 to 10,000, as you can see here. You know, we're measuring 0 to 10,000. The alarm set points for this is usually right at 10,000, because as you can tell from that release a moment ago on the video, yeah, that's a lot higher than 10,000. And usually when these are going off, they're going off full scale. You're usually getting a pretty good stink coming out of those. And so the alarm set points are typically maybe a 5,000 warning, but usually it's a 10,000 ppm shutdown or pump down or trigger to the folks, you know, inside that, hey, you know, this is our only alarm. Let's go ahead and tell those guys to shelter in place for a moment before running out of the building, because that ammonia alarm is outside while some of these other ones might be inside. And so, you know, you don't want to run everybody outside if it's this one that's going off, you know, whereas if it's a high level compressor room leak, then maybe it makes sense to go ahead and get everybody heading out the door in the opposite direction there of the compressor room. But do you guys have any questions on that so far?
I think
No?
we're good. Yeah, we're
Okay.
good.
Okay. So one of the things that I've been showing the benefits as far as uh, the benefits of setting up a Modbus system compared to a home run system, right? And a lot of times it might not be blatantly obvious, but with Modbus systems, they are kind of handy, you know, there's a lot of existing systems out there, manning panels as well, that all had home runs, you know, being sent to them. You know, a lot of them might look like manning panels, like for instance this right here. Some of the old GM10 manning panels I know were really common, and still a lot of people are using them. You know, even the old M20s, at least this had a calibration mode, but this old standalone manning panel system here, this had no cal mode. There was no turning off those shunt or output functions or calibration mode to keep you from tripping your output audio visual or accidentally shunt tripping the compressor room when you were trying to maintain your sensors. So having a standalone system, that does make it kind of handy, because you're supposed to be calibrating these sensors every 10 or every 6 months, right? And so if you had this old system and you were actually going out there and full scale testing the output functions, unless they had a bypass key, you were typically shutting down every 6 months. Well, a lot of folks are okay with testing their shunt trip annually, you know, like the codes say. A lot of folks want to test it every 6 months. And that's completely fine. That's being more safe. I know it's a little harder to restart those systems sometimes, but if they're ready for it, it can be done fairly quickly if there's not a lot of food processing going on there. And if it's, but a lot of the guys, when they're ready for it, you know, they can get the system restarted fairly quickly. And so a lot of these systems here, these older systems, they're just like our old system here. You know, all these sensors, you had to take a Belden cable, 8770 or 3-conductor shield in and pull every single sensor back, you know, to these systems from every single point. So you might be going 500, 600, 1,000 foot across that facility and having to pull a cable for every single one of those sensors. Well, you can imagine, you know, cold storage locations average about 25 sensors, and food plants are typically real close at 25 to 35, you know, depending on the food, the size of the facility. So those are average sensor counts for our industrial environments here that we're into. And we do notice that they're on the same scale dairy plants, you know, the food plants, cheese plants, or, you know, any food production or rendering plants or processing plants. They're all, you know, right there in that average sensor count of 20 to 30 sensors. And the Hornstrobe accounts that we've seen over the last 5 to 7 years have actually doubled, or not only just doubled, but quadrupled. We used to see way back in the day, that there wouldn't be a lot of these Hornstrobes in these systems. But now they're really catching on with these output functions and really keeping an eye on them. You know, we're supposed to be 15 dB above ambient noise, right, in all these areas. So if you're out there at a freezers and coolers and it's loud out there, you know, these 100 dB Hornstrobes you might have one every 60 feet or one every 100 feet, and people are realizing, well, that's not quite enough. And so luckily, because they are 24 volts and they only draw about 150 milliamp, a lot of folks just come in and they'll just daisy chain more sensors out there right off of those Hornstrobes, just to add some more audio visual in the area. And so that's one of the things about it, though, that makes it nice, that that's where CTI would try to power the sensors with the 24 volts right along with slamming relays in here to trip on that audio visual at the same time, because now you're pulling that same 24 volts all through the same conduit, which saves a little bit on labor. And same thing with stack lights going around the compressor room as well. You know, being able to pull and daisy chain stack lights in and around the compressor room for determining levels of concentration. Uh, so what happens though is if you're over here and you expand your freezer system, right, and you're out here at cooler at freezer 5, and now they come and they add on to your building, and they got freezer now, 6 through 10 clear out here. Well, to update some of the other systems, you'd have to come back in, of course, and pull wire, expand the expansion modules out, and pull wire all the way back out to those new buildings and new areas to get them covered. And you'd have to pull more wire and maybe even more power supplies that you need for powering your lighting. That's your additional lighting that you're going to need out there too, right? And so that's quite a bit of labor to have to pull all that clear through the entire new add-on. When Modbus systems are a little bit different, and in that way, they allow you to actually daisy chain these sensors with a module here that can be addressed uniquely with an 8-position dip switch. And so you can, what's nice about these Modbus systems is that for future expansion, or if somebody came in and said, hey, we found out we didn't have enough of these horn strobes, we didn't have enough of these horn strobes out here. We would really like to have some of these horn strobes, carried on from out here off the same circuit. But maybe it's another 300 or 400 foot at the other end of the building. Well, what is nice about Modbus is that you can come right out of here and go back out, and you can add more sensors, right, to that chain. You don't have to come back to where this controller is located. This controller might be over in the MCC area or in the refrigeration office area. Clear over here, another 400 foot on the other side of the building. Well, while you're sitting there trying to pick up sensors another 700 or 800 or 900 foot on this side of the building, well, it makes a lot more sense to be able to just come in and pull wire from your last cooler to your next cooler to your next cooler and add those sensors in that way. And doing it this way really sets up the Modbus systems for future expansion. It sets them up for future gas detection. If you come up, or if there's another gas out there that you might need, or if you started doing CO2 on your dock, along with your ammonia sensors out there, you can come right off here and add the CO2 sensors because you decide you're going to do some dry ice, right? Or battery room sensors going past the battery room, and you needed a hydrogen room sensor in there. Well, you just come right off here and add your hydrogen sensor in there, because on your readout, you can show pretty much any group of sensors that you want on here, and you can go and you can say, hey, there's my sensors, here's my group selection. I want to see my shipping dock sensors right here and here and here, and I want to see, maybe I got 10 shipping dock sensors, maybe I got 10 air units, and I want to see all them on this one screen. So you can add all those sensors on one screen, and you can then go in and put all your sensors on there that you want. If you wanted to, you could open up another window and drag that over, drag this over to another window, and add another screen or another monitor for your air units on the roof, and leave maybe this one for all just your ammonia in the compressor room area. So you got a lot of functionality in how you want to view those sensors as they're and maybe you want to put them on a big screen. You can do that as well. So it really with the Modbus systems, web-based systems, the monitoring side's already covered, right? So the PLC guys also want to be able to take this data. So if you decide to go with the standalone system that you can back up on your dedicated branch circuit and keep everything powered up and running for a while, you can feed this data straight back on the register. So any sensor on the system, concentration wise here, can be fed back through the internet as long as you connect the system to the internet, which is a fairly easy thing to do. This is the actual inside of the system. You can connect it to the internet right here. And as long as you're connected to the internet, you are going to be able to see all those values, the values of those registers that's capturing that sensor concentration in parts per million, and it's capturing all these relays. So when you turn on coolers 1 and 2 horn strobes, you know that that zone of horn strobes has been turned on without having to make any connections because you're already on the network. So the refrigeration controls can see this, and it's nice to be able to have that, so you can get that data over to them as well if they're doing anything special with the refrigeration controls output relays. Most of the gas detection systems that we see here, when they're standalone gas detection systems, whether it's CTI or Manning or Cool Air or a Draeger, or they all tend to have control over the really important relays here. Usually when you open up a standalone system, especially at the compressor room, you'll usually see the shunt trip in here, right? The shunt trip is got to be able to shut down the compressors and the king valve and de-energize the entire compressor room at sometime before 25% of the LEL for ammonia, right? And most folks do that at, it's changing every day, but and getting lower and lower as time goes on. But most of the big guys are doing a 1 or 2% alarm shutdown because a lot of times they'll do their own response, and when they shut down, it might be thousands and thousands of dollars a minute. And so if they've got their response team that can get out there real quick and mitigate a leak and save some money, they might turn around and just and have that set point a little higher, like say at 2%. And maybe they want to be the ones that actually perform that shutdown, whether it's on the high side or the low side of the system. Because as we know, if you shut down a system and the leak's on the low side, then that leak could get bigger. So it's really up to the plant and the safety guys to make that decision. But they do say that the system does have to be 100% shut down and de-energized by 25% of the LEL, and which the sensors that we're talking about here, in the compressor room, they're doing it way, way, way ahead of time, right? If I like always saying that the old numbers used to be 16%, right, for the LFL, the lower flammability limit for ammonia. It's actually really closer to 15, but I always said it's 16 because it made it easier to say, okay, what's 25% of 16? Well, 16,000. Well, that's 160,000 ppm. Well, that's 40,000 ppm. So the magic number is 40,000 ppm if you're calling a flash point 16, or the flammability point at 16%. Well, here we are doing it ahead at 20,000 ppm or sooner. So you can see that we're being really safe here, and that we are doing it way, way, way ahead of what OSHA is wanting to see, that all these intrinsically potential things to be shut down. They want to see that shut down and no chance of any sparks or anything in there. So is there any questions on that?
Guys got any questions?
Okay.
Yeah, we do.
Sure.
So Andy, at one point, we've been, a lot of talk about that battery backup for these ammonia detection systems. Do you know
Yes.
how long how many hours we're supposed to back up that power for?
They didn't say in here.
I know. So I
So,
have 24, which I think is humongous for a battery backup.
well, what I'd tell people, because I've had so many people say, well, what are you guys saying about this? Well, I like using Bill Lopp's definition, since there is no time frame called out here in RMP. So we get to say we're going to take the next best data that we have, which is the NFPA codes, right? So on the NFPA, that allows us to that's going to allow us to turn around and say, hey, we want to do it whenever before the 24 hours. So we're using what the fire codes are saying, the NFPA fire codes, right? that makes sense to take their guidance, because they are the authority having jurisdiction anyway already, right? The fire chief over this area, he is the authority having jurisdiction. Now he can divvy it out to the county auditors or whatever he wants to, but he is the guy that has to make that decision. And so if they're okay with it being 24 hours, then I'm okay with it being 24 hours as well. The problem with doing and figuring out these UPSs on these systems is that when you're running anywhere, like we were talking about before, these horn strobes now, to really meet that horn strobe, objective and get so many of these horn strobes out there. Yes, they might only draw 150 milliamps, so every 10 of them is 1.5 amps, which is not a big deal. But when you're trying to carry it across, 1,000 foot of cable and thousands of feet of cable across an entire facility like that, and you end up with 50 to 100 of these out there, now we're talking some juice, to keep these systems up. And when I've done the research on it, it really didn't make a lot of sense. The cost of the rack mounted, first of all, the real estate that it takes to get them up on the wall, to back up a system for 24 hours is surprisingly a lot. And to back up that many horn strobes and keep them going as well, because you got to be able to keep the lighting going if you're going to keep the sensors going. What good is the sensors if you don't have something telling a guy not to walk in there and into liquid on the floor? So we're powering everything with 24 volts, and we put the UPS, on this system. And that UPS that you're seeing in the design documents, really what that is, it's not to sit there and allow this system to run forever, right? It's not going to say, hey, it's not even there to let it run for the 24 hours. It's really there to take the switch gear bang off that of that dedicated branch circuit that's kicking in and that's powering this now UPS right here. So we put a 200 VA amp system on this, and really, if you're looking at this drawing, and with everything that is running right here, just on this drawing alone, we're going to be able to stay up for several hours, maybe even a half a day, which the leak would more than likely be mitigated, and most of the day maybe, and the leak would more likely be mitigated. But as far as trying to keep up a huge system where we've got 100 of these horn strobes out there and 25 to 35 sensors out there, you're talking a lot of money, and you're talking about a whole wall of rack-mounted UPS batteries set up to do that. And so what I've always told everybody is that it makes sense to have a generator, because number one, if you're not sheltering in place, right, and there is the ability that we're going to leave ventilation running, if power goes out, ventilation is supposed to be on that same generator circuit. It's got to keep the fans moving, because we can't have that buildup of ammonia inside the compressor room, right? So the fans were always supposed to be, in my understanding, at Bolton 111, I thought, as far as backed up and still running, in order to keep the ammonia from building up inside the compressor room, because it's really, really hard at 20 or 30 air exchanges to even get over 15,000 ppm in here, is my understanding. And so when you're moving that much air, you're always going to be safe, right? If the fans stop, that's where it starts getting questionable, especially if you've got MCC buckets out here, or relays out here, which there's never should be anything, relay wise out there, but I know some places have. But as long as you're really moving the air, you're pretty safe. So my understanding was this setup is just to take the bounce out. When somebody hits an e-stop, that generator circuit kicks on, it starts feeding the power back to the safety equipment, right, and to the ventilation, and to keep maybe high priority goods that cost a lot. I don't know, keep them cold. I don't know what all goes on with that circuit. There's so many different things that it could be running in a facility. But a Modbus system's kind of nice in the way that the system can step some of its power down in a way where you're not really using so much power, at least on the sensors end, so that you kind of take away 350 milliamp of a draw on each sensor in the freezers, and maybe it goes to 40, because now you're in band-aid mode and you're running off of this thing right here. Well, you don't want to try to run 350 milliamp off each sensor when you could be running 40 or 100 during during an event where you don't have power. And so I know that's some of the things that have been talked about on the gas detection side on our end, as far as doing something like that as well, to really help get as much time and less drain on that dedicated branch circuit or UPS rack mounted system, that a person might go with. I looked at Schneider Electric, and I'm trying to remember the I think it was 10,000 or 12 or 13,000 kilowatt or voltage amps, if I'm remembering correctly, to keep a system up for like 24 hours or 48 hours. I guess I was looking for 48 hours, because I thought, well, at first I thought that RMP release was 48 hours, but they didn't ever give a time. I thought I had read 48 hours, and apparently there's no time in here. So they don't tell us what that looks like. And so at that point, the only thing we can do is go back to the fire codes until they designate that out. I hope that answers the question. I know I was kind of all over the place there in answering that, but that's a tough ask on, number one, the way they are doing batteries, and to try to carry batteries and ship batteries through UPS and those lithium ion batteries. It's just a really big pain to try to do that. And so I've aimed people at Schneider Electric's website and looking at some of these rack mounted systems where you can start off with a few 3,000 VA batteries stuck into this rack mounted UPS, and then somebody comes in and says, well, that's not going to keep you up for over 24 hours. They did the math on it, and it might keep you up for 20 hours. Well, okay, I'll just add another 3,000 rack in here. There's another 3,000 battery, and just add another battery in there, to be able to pull it off. And so you can build those UPSs as you grow your system. So I like that idea with them, but it just seems like a fortune. We're talking 150. If I'm remembering correctly, it was pushing. What was it pushing? It's pushing 15 to 20 something $1,000, I think, if I remember correctly. And I started thinking, well, that's not too far away from a Generac generator at this point. That might get you, what, 30 kilowatts that you can power off of it. So you got a lot more power, off a generator. So I think generators are we're going to find out generators are what's going to be the dedicated branch circuit backups on most of these facilities is my thinking. So, and maybe there's some guys out there that might not know more about this battery backup than I do that's in this meeting. And if somebody has some other input on that, please share, because, this just came out, March of 24, and I'm still trying to play catch up on, other than referring to the NFPA codes on what the game plan really is for what CTI should be recommending. I always thought it makes sense to do generators, but that's just because of the amount of the load and because of keeping the ventilation going and some of maybe the lighting as well that needs to be intact in order to get people evacuated safely. So that's kind of my feeling about it.
That's what we're seeing as well. They're leaning towards generators. Initially, I wasn't a big fan of standalone detection, but power up at 12C is substantially more than a standalone detection system.
I'm sorry. I'm having a tough time hearing you there. I've got my head right down here on the laptop trying to hear the best I can. Is there a mic or a way that you can say that again?
Yeah, I moved closer. Can you hear me?
Oh, here we go. Perfect. Yeah, that's perfect.
So we're seeing the backup generators as well. Initially, I wasn't a big fan of standalone ammonia detection controllers because it was easier to go to the PLC. But because of wanting to keep the detection live for so much longer, it doesn't make sense anymore because the PLCs have racks all over the place. And now you have to battery backup every one of them, and they may not be on the same circuit. That makes it a much more challenging project, where a standalone system, you can bring in one dedicated circuit or off a genset, and your ammonia detection is still active and it can still fire the relays necessary to protect the employees.
Yeah, I'm 100% in agreement. I know when it used to be, I always heard rumors that IAR was going to try to move towards that in the standard, and I thought it was supposed to happen in what was it? Was it 2014? And then we did 2021. At first, we thought it was going to happen in 2014, and then we thought it was going to happen in 2021, and then it kind of just went away. So I'm hoping it does come back, because that does make sense. I think you're exactly right, to be able to bring in your power, into one board, and then have it power all the sensors and all the lighting, on one circuit like this. That does make a lot of sense to me, for trying to keep the safety equipment up on one circuit. It's and that was one of the things that CTI was looking into. Right now, we don't do it off these particular sensors, but I let me see if I've got a picture for you guys. I think I might have a picture for you guys. It was shoot, I got an email today. Oh, I know what it was from. It's from LinkedIn. This is the first time I've even seen it, but we've got actually, let me see if it's on one of my emails. This is the first time I've even seen it. This is the first pictures of the M1. Here it is. There it is right there. So control. So this is CTI's new M1 sensor. So what you guys are used to seeing is probably, like this right here on these, the legacy stuff that you're used to seeing. This M1, I know that they've talked about, we didn't want to leave anybody behind on this Modbus system, so we developed this 90. This basically takes, you can see right here that the sensor is connected to this. The 4-to-20 sensor sticking the 4-to-20 into this Modbus module, and it's just converting it, and it's allowing it to go onto that Modbus chain right here on that A and B Modbus comms, and then you just power the ground to it, and then you assign this dip switch an address. And the way that works is these will all have a QRC code on it. And so when you click on the QRC code like this, what ends up happening is that it pops open like this, and you say, man, what is sensor 11 supposed to look like? Say I'm on sensor 11. I have no idea. But okay, so that's what 11 looks like on an 8-position dip switch, because my discrete's a little rough. Well, what if it's sensor 111? What's it look like there? Okay. Because we can do up to 255 devices on that. So if that's sensor 111, then I would just match that exactly with this one and open up the door of the enclosure and say, hey, this is, Modbus channel 1 here, and that's going to be sensor, 111. So CH1 pound 111 tells me, hey, this is on channel, or excuse me, down here. This is on channel 1, and it's sensor 111, right? And so on this particular system, we can go out 4,000 feet on this run. We tested it out to 6,000, but you can go out to 4,000 feet. And one of the things we did do is we added these remote relay boards out there. So anywhere along the way is like we were talking. If you need to add some stack lighting or horn strobe assemblies out there, or if you're picking up another standalone system along the way, you just add these analog input boards, or if you got an analog output board feeding the PLC, or if you got some relay outputs you're wanting to put a new zone of lighting in, it's a lot easier just to daisy chain in these IO boards. Here's a discrete IO board, and they all got that same dip switch. You address them the same way, and whichever one is the last one at the end of the line. So in this example, we're coming off of this channel. and we're coming down and we're going sensor 1, 2, all the way out to sensor 120, because we don't want you to put any more than 120 devices on one channel. But you get out here and you come this way, here, and then you run this way. It goes to this board, jumps to this board, jumps to this board, and jumps to this board. Well, this is the last one on the end of the line. There's nothing else running out here. And when it's the last one at the end of the line, there's a little EOL switch. You just throw that. And that terminates the Modbus channels on most of these Modbus systems. And that's how you'll see when you hear EOL, that will tell you that that's an end of line device. And that should be terminated. And that's basically, that tells this system when it shoots the frequency out and it gets down to here and it bounces back, it sees that that's the last board and it bounces it back. So it keeps the communication straight, right? And so anyway, that's how Modbus actually works, as compared to like right here. We didn't forget our poor old guys that bought the GG6. Maybe they want to update or maybe they got a GM10 panel or one of those old Manning M20 panels. Well, they still got to have home runs somewhere, and that's why we left these 8 in here. So if you have an existing standalone system with home runs coming in, as long as you got 8 or less locally here, you just can pull the other one off the wall and re-land the sensors into these channels, up to 8 of them. And then you can re-land all your dry seat contact relays out of the old system into this one, and you can do a drop-in replacement. So it makes it pretty easy, really, to upgrade to these web-based systems. And then that gets you, a nice little GUI that you can, you now have capability of tripping any relay on the system if you want to. If I want to go to calibration mode, it's pretty simple. I can go here, and if I want to go to a group of sensors on the roof, I can say, hey, there's my HVAC sensors on the roof. I'm going to just go calibrate them for right now. And so I need 3 hours to time this. So I'm going to jump my timer up to 3 hours. There we go. I'll stop it and then restart it with 3 hours. There we go. Now everybody knows that we're in cal mode on some group of sensors out here somewhere. And that's pretty handy, because it's going to time out and never leave you vulnerable on your system, which can happen if somebody doesn't forget to go back and take the calibration mode off, or if it don't time out on its own. So that's a safety one that we wanted to put in there. And we also wanted to put in not only for groups of sensors, but we also thought, well, what about the guys that just want to calibrate all their compressor room sensors, but not that high level sensor, not that 0 to 20,000? So we can go ahead and take it offline for a few hours. We can go calibrate everything else, and we'll know that we're not going to accidentally shunt trip ourselves and disrupt operations and get in trouble. So we tried to throw everything we could in here, and that made sense to add this stuff in here to make it really helpful. And then once everything's calibrated, you can highlight and update the calibration on all your sensors here automatically. And when you're setting them up, you got trend lining. I blew into this earlier on today, 8 hours ago. I guess it's been a little ways there. So we have some pretty good trend lining from where I was having them blow into that CO2 sensor out there at the CTI office. I got a guy that sits right around the corner there, and I'll tell Randy, go run around the corner and breathe into that 0 to 2,500 sensor, and you'll just see this thing start climbing up, and you'll see all these colors come across the screen at those alarm set points when this raises up. It's pretty neat looking. And so usually he's not there tonight, or I'd have him go do it. But unfortunately, he's not going to be hanging out at the CTI office this late. So, but anyway, I thought you guys would like to see that and hear about the differences, in these systems, and the benefits of being able to just add some remote IO boards on the end of the line when it comes to, adding additional sensors or relay outputs or zones of horn strobes. It sure does make it expanding, in the future a lot easier than what we've got going on right now. So, so labor should be coming down on these systems, is what the goal is here. And let's see here. I'm trying to think. I don't think I really had too much else out here. Let me see what else I had on this that I wanted to show you. Oh yeah. So one other thing that I wanted to show was the input channels. So here's all your detector inputs. And so on those 8 that I was showing you guys in the middle, here they are right here. The 0th A1, I mean analog 1, these are all those onboard connectors, that's sitting right here in the yellow. So those are all the ones that are local. And then when you see a D on them, you're going to notice that, okay, we know that those are going to be the digital analog ones. And then, or excuse me, when you see these numbers on them, you know that this is an address sensor. So for instance, this is an analog input board. And so there's A1 through A8 analog input. So this board would be like what you're seeing, out here as on that example where that sensor was tied into it. So it would look like this right here. So that would be an analog input board right there, because we got a 4 to 20 sensor going right to an analog, one of the 8 inputs of that board. So that's what it shows up as on the controller. And so when you look at that 8 right here, that 8 is going to be that dip switch. So that dip switch, if we go in there and we go, that dip switch will be set for 8 or Modbus ID 8. So if we went in here and said, okay, what does 8 look like? I think we might be able to figure that one out, because 8, that should be what? Mine's a little rough, but I think we just go 2, 4. It would be just the 3 up, right? I can't remember. My discretes are so rough, I couldn't tell you what 8 looks like. I think it is just it's okay, 4 up. So there's your 8. So that one would be addressed to 8, if your guys are getting that. And so that is what we would expect to see, on the system. But the new M1s, back to those are going to be 0 to 250 range up front. And then we're also going to say with display or without display. And then there's going to be an option right here that I really like, and that's going to be 2 relay outputs. So they are actually going to embed 2 more relays on this board, which really gives you a lot more choices. It's not going to be specific to this sensor, but it will be specific to any of those relay outputs that you're looking at off this system. So if we go like this and we want to look at the output relays, there's our 8 right there that are on board that we talked about. If I hit relay 7, I can see there's nothing configured for that one. So if I want to add that relay 7 and want to make it latching and make it silenceable, so say that'd be a horn strobe assembly, I could say add configuration. I could choose the detector that's on the system, a group of sensors on the system, or I could just go to a specific detector on the system and it'll switch back to all the detectors that I have up there on that screen. And then I can say, okay, or I can do a discrete. So I got 4 discretes that somebody could just press a button and turn on lights if they wanted to. And so there's gives you a lot of options. You could add that for any sensor alarming. I'm going to trip that horn strobe on this relay 7, and of course make it active, and then call it what it is. And so that's how easy it is to program a relay. So if you're troubleshooting through here and say, hey, I'm not seeing this relay 8 trip, you can go hit relay 8 and go look and see the configurations underneath it. And you say, well, no wonder it's not tripping. Nothing's programmed here underneath relay 8. I want to add something. So that's how easy it is to actually program these relays and to get some output functions happening there off your system. So is there any questions on all this stuff here? I know I've covered a lot, and I think benefits of a Modbus system really is going to outshine these older home run systems, just because the labor involved in trying to do these things is insane, and the cost of this cable's going up too, like a fortune.
Yep. Now, this was a great presentation. The only other question I got was handheld or personal ammonia detection. If you could bring that up. I think the new blue, I forgot what it's called.
The Wingman.
Yep, that's it. Some of the members might want to see that.
Yeah, it's going to be under portable gas detectors, and we've got it right up here at the top. So we got the old first full range responder, which we've been selling forever, and that one's good for level A response and stuff like that, but it's pretty expensive. Just for the guys that are just trying to get by having something to, in case the auditor shows up, this Wingman's a pretty good unit. It's so lightweight that you can pack this around on your hat probably, and you wouldn't even hardly know it's there. But we tried to spin it off the old BW Extreme looking little yellow one that they quit selling that everybody loved because it was so small and lightweight. So we virtually tried to do the same thing they did. In fact, if you look at the clip, you remember how good those clips were. If you were falling down to a chute ladder, this would probably catch you and hold your whole weight and probably save you if you fell down the chuted ladder, because this thing is very robust and you're not going to get it off your belt once you clip it on there. So there's no knocking it off. We did a 25-foot drop test on it when we first did it. It busted into a bunch of pieces. And so we went back to the drawing board and we rubberized this a little bit more. And then the last one at 25 foot bounced across the whole CTI production floor and survived the fall. So they're pretty robust units. There's a lot of people that, well, they don't record the data and this and that. And I always say, well, you know what I do? I basically hold this up in the air, and then I put my camera off my phone and behind it, and I look at the leak that's behind it. I did this out in, I was out east, and I was recording the concentration as I'm looking at the leak. To me, that is so much. If your EHS manager gets one of those from you, he's going to love you. You know, you can't really beat something like that on a text message for, hey, what are you seeing out there for that leak and concentration wise? So, anyway, that's kind of what I've always said when somebody's asking about, well, where's the data logging? This thing's pretty not a lot of money, and we don't do the data logging on these, so like some of the other guys do, but we've had pretty good luck with it. So
Okay, Andy.
and yeah, I appreciate it.
We appreciate your presentation.
Yeah, thank you very much. I appreciate you guys having me come in. I'm trying to find the Zoom meeting so I can quit sharing here if I can find it. I'm not. Oh, here it is. Stop sharing. There we go. Yeah, guys, thank you very much. I appreciate it. If you guys have any questions, please feel free to give me a holler. I'm at andy.neptune at of course the website there, ctigas.com, and you can shoot me an email anytime, and I'll try to get back with you as soon as I can if you guys have any questions.
Perfect.
Great.
Thank you.
Andy. Appreciate
Thanks,
it.
guys. Have a safe trip home.
Yep, you too. Enjoy the night.
Bye-bye.
Shane, you need some help picking up these things?
No, I learned a lesson too. I can get I can get the TV going now.
I didn't hear you.
I can get the TV sound now, so I'll be all right.
Oh. Yeah, I don't even think these were running.
No, I couldn't get it to work off the Zoom, but I was playing YouTube earlier, so I'm not sure if it's the app or whatnot.
Okay.
So
These are pretty badass.
they are.
I
I'm gonna
think-
save them for other times.
Yeah. Yeah, these were pretty cool.
I reserved the Gas